testing, and you said in this case here that a hypothesis is a belief or an opinion that can be tested. It can be tested mathematically. So for example, somebody can come and make an allegation, say that if you invest like 1 million Kenya shillings in a particular kind of advertisement, with this kind of an investment, you'll be able to draw, like, for example, 2,000 students, right? So what I'll do for me to say that that is a hypothesis that is testable mathematically, I'll ask in this case here for evidence, historical evidence. So I'll look at, for example, in the past, we put in 50,000 into our advertisements and got 10 students. We put in 100 and we got this. So the moment I see that for sure, the more I'm putting in, the more I'll be able to get, then I'll be able to say that this 1 million allegation that you've told me will be able to give me this 2,000 is something that I can be able to defend and prove mathematically. So hypothesis is a testable allegation. A mathematically testable allegation is what we call a hypothesis. Now, I'm so sure most of you guys must have watched my hypothesis video, and I don't want to belabor in this concept because of our exams. I would want us to be very specific on which hypothesis would we want to test. Which hypothesis would we want to test? And for purposes of timing our exams, I would want us to time this from the hypothetical or other hypothesis area, 3 areas under hypothesis, right? Yeah. Yeah, we could start with illustration number 1 here. Illustration number 1. Illustration number 1. Illustration number 1. Illustration number 1, we are told 10 oil tins are taken at random from an automatic filling machine. The mean weight of the tins is 15.8 kilograms and the standard deviation is 0.5 kilograms. Does the sample mean differ significantly from the intended weight of 16 kilograms? Of 16 kilograms. 10 oil tins are taken at random from an automatic filling machine. The mean weight of the tins, which they found there, is 15.8 what year kilograms with that standard deviation. So does the sample mean differ significantly from the intended weight of 16 kilograms? This is quite a very easy question. I know somebody on hearing the word hypothesis, ladies and gentlemen, they fear a little. You should never fear at all because this is something very simple. Look at, for example, whenever we have this Kenya, officers from Kenya, Bureau of Statistics raiding some supermarket or some production, say bread production plant. What they'll do, they'll go there and pick a few loaves of bread from the shelves, and then they'll weigh them, right? When they weigh them, of course, we know in Kenya here, a loaf of bread in terms of weight keeps on going down every other day. Right now, you're talking of about 400 grams, right? But we know that 400 grams is even what they're putting on paper. But if you're to get a weighing scale, chances are you'll even get this bread being about 300 grams. So of course, they'll pick like a sample of 10. So these 10, they'll weigh them. And of course, they'll come up with an average weight. So these people have been able to get an average weight of 15.8 kilograms. And yet the company itself had put a label whose weight is what here, 16 kilograms. So then they want us to carry out some small test here. And in this case here, test whether the mean of this sample is different from the mean of the population. The mean of the sample chosen here is 15.8, and then the population's mean is 16 kilograms. Then how do we roll with this? How do we roll with this? This is quite an easy roll, So what we shall do, ladies and gentlemen, first of all, will be to define the hypotheses. Let's define our hypotheses. We have got two types of hypotheses here. Hypothesis. So we have here the first step is a hypothesis definition. Hypothesis definition. Of course, we have what we call the null hypothesis. So the null hypothesis here is where the manufacturer is now making his allegation. What allegation is he making? The fundamental allegation here, of course, this null hypothesis will always be denoted like that, H0. So the allegation that this man or this lady is making there is that his sample mean, right, is exactly equal to the population mean. Hata kama najua menyanganya kidogo, hata kama najua mikate haitoshi weight ile ambayo ameweka kwa label, yeye anasema kwamba the samples you guys are going to take from my shelves here, weigh them up, the sample mean will always be equal to the population what here? The population mean. Remember, X bar stands for what here? X bar stands for sample mean. X bar stands for sample mean. And the U or mu stands for population mean. I want to believe you guys have done that. And then now for us, when we come here, when we come on the table, we must also put down our alternative. We must also put down an alternative hypothesis. So in this case here, we have alternative hypothesis. So the alternative hypothesis, which will be H1, will be the one that is going to prove that this mean, sample mean, is not equal to the population mean. When you cross like that, means not equal. Not equal. So X bar is not equal to who? Is not equal to U. X bar is not equal to U. X bar is not equal to U. Great. Now from there, we go to the tool. The hypothesis testing model. So the hypothesis testing model here, the hypothesis testing model, you must know the size of the sample that you have. The sample that we have, the N here, is 10. N is 10. N is 10. These guys took how many pieces of this product? And they took 10 oil tins. They took 10 oil tins. They took 10 oil tins. So N is 10. And when N is 10, ladies and gentlemen, when N is 10, this 10, N being 10 is a small sample. Small sample because it is less than what here? It is less than 30. It is less than 30. N is 10, N is less than 30. And if it is less than 30, then this is what we shall call a small sample. And if we are calling it a small sample, ladies and gentlemen, then we shall use the T statistic. We shall use the T statistic to test this hypothesis. Remember, you could either use Z or what here? T. Z is for large samples. Samples whose N is more than 30. We use Z. Small sample, you use what here, somebody? You use T. Small sample, you use T. Small sample, you use T. Small sample, you use T. Volume. Wanasema kwamba they are not able to hear me. What could be the problem? What could be the problem? Because from my side, I can see my icon is 100%. I can see my microphone is 100% doing very well from my side. From my side. I don't know from your side. You should be able to hear me. Yeah, very audible. Yes. So the students who are not able to hear me, I don't know whether you could communicate to them. you simply log out and then you come back to Zoom afresh. Because when sound is not there, I'll be able to know from my side very fast. It's okay. It's okay. It's okay. So now we can continue. We can continue. So what have we said? Small sample, we use what here? The T statistic. And then the large sample, we use what here, somebody? The Z statistic. We use the Z statistic. Now, ladies and gentlemen, here, this examiner has not given us the level of significance. Remember, in most cases, the level of significance, at what level is the figure significant, will always be given. If the level of significance is not given, you assume it yourself. The level of significance is not given, assume this level of significance yourself. So in this case here, assume the level of significance, assume level of significance to be what there, somebody? To be 5%. Assume the level of significance is what percentage there? Is 5%. Assume that the level of significance is 5%. Assume that the level of significance is 5%. Now, ladies and gentlemen, if it's 5%, I'm going to put down my T model. The T sketch looks like just the normal Z. But now this time around, this thing is going to have how many tails? 2 tails. I'll explain why. 2 tails. And the total shaded area, the total area of the tails must carry the entire 5%. So in this case here, each tail will be 5% divided by 2. Each tail will be 5% divided by 2. Whatever level of significance you've assumed here, not a problem. That level of significance has to be shared out between the 2 tails. Has to be shared out between the 2 tails. So each one takes a half. So a half, this is what here, somebody? This is 0.025. 0.025. 0.025. This one here will be 0.025, like that. 0.025. And of course, in between here, then we'll have 0.95, given that the total area must be 100%. Given that the total area must be 100%. Now, if I could take a minute to remind you, you see the alternative hypothesis, we want to prove that the 2 means are not the same. That is what we want to prove ourselves as a staff coming from Kenya, for example, Bureau of Standards. We want to prove that the 2 sample means are the 2 means are not the same. They are not the same. So when you say not the same, it means that if we have our sample mean being less, then that means what here? Our alternative hypothesis hold less, or if more. So we will talk of 2 tails. 2 tails. Listen, ladies and gentlemen, if this alternative hypothesis was to read like this, X bar is more than mu. If we say X bar is more than mu, then what I'll do is to come and have one tail which is on the bigger side, one tail which is on the bigger side, more than. But whenever you see this equality being struck off once like that, not equal, it means straight away you have what we call the 2 tails test like that. 2 tails test like that. It may look a little bit strange, but you love it. You love it. Trust you me. You love this. It's an easy thing. It's an easy thing. It's an easy thing. Now, ladies and gentlemen, having been able to draw this thing nicely, then I need one more thing. I need actually 2 things. I need 2 things. I need 2 things here to be able to read this from my table. I need 2 things. Number 1, I'll need a V. V is the degrees of freedom. Degrees of freedom. V stands for degrees of freedom. And these degrees of freedom, if you look at this very well, degrees of freedom, to get degrees of freedom V, we normally talk of n minus 1. To get degrees of freedom, we normally talk of n minus 1. So n in this particular case, n ningapi, somebody in this particular case, we're told n is 10. So it will be 10 minus 1. So 10 minus 1, this gives me 9. 10 minus 1 gives me 9 years. And then number 2, I need, in this case here, I need this level of significance. the level of significance, this 5%, I really need it, 5%. Alternatively, for you to be able to get this straight from your tables, what you will need to be able to read the T, you will need what we call 1 minus alpha over 2. 1 minus alpha over 2. This is something else that we need. So then this will be 1 minus 0.05 over 2. Remember, this 2 is only cutting the level of significance. So could you kindly give me this? This is the second thing, the second requirement that I need. This is the second requirement that I need. To be able to read from my T table, I need two things. I need the degrees of freedom, and I need 1 minus alpha over 2. Could you kindly give me this 1 minus alpha over 2? Please confirm with us whether it is 0.975. 0.975. Is there anybody who is able to get 0.975? Winnie has gotten that, but Winnie is only one student. I mean, how about the other students? What were they able to get? 1 minus 0.05 divided by 2. 1 minus 0.05 divided by 2. That gives me 0.975. 0.975. 0.975. I need these two things. Now from there, now please go to your table. Please get your past paper and go to your table, and then you look for a table called student T. Student T, you know, a student is smaller a little bit. Like now here, I'm the teacher. Teacher is a bit bigger. Student is smaller. So student T is for small samples. It's for small samples. Is there somebody who has been able to remove that table called the student T? Do we have any student who has been able to see that table called the student T? Yes, Jerry says yes, Jerry says yes, Jerry says yes. Winnie also says yes. So I would want you guys to do me a favor. If you've been able to get that table there, I would want you guys to do me a favor. I would want you to go straight away to that particular table where you are able to see a column of V. There is a column of V. Please go down to where you are able to see 9. And then by the side here, you'll be able to see T.975. This T.975, again, you work with it. Of course, don't exceed. Whatever figure that you have here is what we call the T critical. You know, when I asked whether you guys have the tables, it's only 2 students who told me they have tables. There are tables. The examiner will always give you 2 tables. There is a normal table and there is a student T table. There is a normal table and there is a student T table. Are you able to see the student T table? Are you able to read some figure there? Is there anybody who is able to read some figure? Is there anybody who is able to read some figure? According to Sam Lemayan, 2.262 is correct. Any other student who is able to read that figure there? Any other student who is able to read that figure? Okay, is there a student who doesn't have this paper? Is there a student who doesn't have this table? Is there, do you have a student who doesn't have that table? Oh, okay. Let me see whether I can get one online. Let me see whether I can get one, because this is a very important topic for you people. We have student T tables. Please let me know whether you are able to see my table, my screen. Are you able to see my screen? Are you able to see my screen? Yes, thank you very much. But again, this table is a little bit different, but there's no problem. You can see now, this one here, they're simply giving you degrees of freedom on top, only degrees of freedom on top. And then they are working with only one tail. And our tail, right-hand tail here is 0.025. So what I'll do, I'll come to 0.025 here. and then I walk along the degrees of freedom up to 9, I'll be able to see the 2.2, this one here, 2.262, 2.262, right? Up to 9 there. But I would want to use a table really that we have. The table here that we need. Okay. Yes, this is much better. So you can see we have our T table. When we are talking of one tail, of course, at 5%, one tail will be 0.025. 5%, one tail, each tail will be taking the same 0.025. The two tails will be having 0.05, and you can see our T.975 on top. So when you work with this T.975 degrees of freedom, you can see degrees of freedom here up to 9. When you come here, you'll be able to see the 2.262 like that. 2.262. So all of us, ladies and gentlemen, are we together as pertains this 2.262? 2.262. Have we been able to see that? 2.262, 2.262, 2.262. I would really appreciate your feedback. Okay. I'll be able to get that table. I send it to you, perhaps after class. Thank you very much. Okay. Now there we are. Now, so we have been able to get our T critical. It's called T critical. So T critical, we are saying here it is 2.262. Then this will be minus 2.262, minus because it's on the other side. Minus because it is on the other side. It is on the other side. Now, ladies and gentlemen, we've been able to put down the tool. This is very important for me. For hypothesis testing, we've been able to put down the tool. Now, from there, we go straight away to the last stage. The last stage is now the testing itself. The last stage is the testing itself. So now we are coming to test here. Ladies and gentlemen, our T, how do we test? We'll take X bar minus mu divided by standard error. We take X bar minus mu divided by standard error. This is the testing stage now. The testing stage. So this testing stage, we have this testing stage. This is what we call the T calculated. So the T calculated is T equals X bar minus mu all over the standard error. Now, how do we get this standard error? To get the standard error, my friends, to get the standard error, we normally take the standard deviation given, over root n. You take the standard deviation given over square root of n. So do we have a standard deviation in this question? Do we have the standard deviation in this question? If you look at this question very well, they have given us a standard deviation of 0.5. And of course, n is 10. So then what do we have there? So we have the standard deviation of 0.5, over root of n. which is 10. So 0.5 divided by root 10. Can somebody give me the standard error? Can somebody give me the standard error? 0.5 over root 10 will end up giving me what figure? 0.5 over root 10 will end up giving me what figure? So when it tells me it's 0.1581, 0.1581, 0.1581, 0.1581, 0.1581, 0.1581, 0.1581, 0.1581. Thank you very much. So could you kindly try to substitute them up here and give me T? Kindly try to substitute up there and then you give me T. And try to substitute up there and then you give me T. Tell me what we have. So remember that X bar is what? Is sample mean. I know I did not put the question up. X bar is the sample mean. The sample mean is 15.8. Remember we took these 10 oil tins and measured them, weighed them, and we got their average being 15.8, and the population mean is 16. The population mean is 16. Remember, mu means population mean. So we have 15.8, 15.8, 15.8, 15.8 minus 16 all over the standard error of 0.1581. So I can see Nokia 2.3 has raised, I don't know whether it's a man or a lady, me assume it's a man. So I can see you have raised your hand. Can I unmute you, talk to us? Yes, please talk to us, Nokia 2.3. You can unmute yourself first. I can see your signal is clear now. Talk to us. Talk to us.
Which question is that?
The one that you're doing, it is this question here. Illustration 1. Illustration 1. You can just take a snapshot of that.
Okay, thank you.
Okay, great. So they've already given me answers. They're telling me it is 1.2650, negative 1.2650, like that. That is the T calculated. The T calculated. Now, could you kindly then do me a favor? Please try to locate that T calculated, locate the T calculated in your test tool. In your test tool. Where is this minus 1.2650 in this test tool? Is it in the shaded area or unshaded area? Where is it? Where is it? Is it in the shaded area or unshaded area? Remember, at the middle here, we have a 0 which is encompassed in between. We have a 0 there. We have a 0 there. We have a 0 there, right? So this minus 1.265, if you were to look at this as a number line, where is it? Will it be in the shaded or unshaded? The intended mean is the X bar. X bar, yeah, X bar is, you know, X means what here? Sample, the sample mean, the 10 teams that we took, the 10 teams that we took were the sample mean. This is the population mean, U, right? So then we have here minus 1.265 being correct. And of course, this will be somewhere here in the number line, will be falling somewhere there. 265 negative. So in short, it falls on unshaded area, falls on unshaded area. And the unshaded area, please come and mark your territories very well. Unshaded area is what we call H0. Unshaded area is what we call H0. Unshaded area is what we call H0. This is a shaded area is always H1. Shaded area is always H1. Shaded area is always H1. Shaded area is always H1, right? So in this particular case, you've told me that it falls on some unshaded area, and therefore if it's unshaded area, accept H0, accept H0, accept H0, and conclude this H0 here, and conclude that, accept H0, and conclude that, X bar equals what here? Somebody conclude that X bar equals mu, and conclude that X bar equals mu, and conclude that X bar equals mu, and conclude that X bar equals mu. So then these guys have got no issue. Despite the small discrepancy, of 0.2, they don't have much of a really, the sample mean and the population mean are not statistically significant, or rather the difference between them is not that significant. It is still falling within the acceptable range. So I'm so sure this may have been a little bit technical for you. Let me just check here. The formula is 1 minus alpha over 2. The intended mean is the X bar. Is it possible, ladies and gentlemen, the students who are asking these good questions, could you kindly try to unmute yourselves and talk to us for me to be able to understand you even better? Please talk to us. Somebody unmute yourself and then you talk to us. Unmute yourself and then you talk to us. Unmute yourself and then you talk to us without fearing anybody, anything. Unmute yourself and then you talk to us.
Mwalimu, as of the assumption that the 15.8 is the U, and no, 15.8 is the U, and X bar is 16 because you are looking for 16.
Let me explain here. You know, it's not about what you intend to do here. It is about X bar. X bar is the sample mean, always. X bar is a sample mean. 10 oil tins are taken at random from an automatic filling machine. The mean weight of the tins, which tins? The 10 that were selected. The mean weight of the tins is 15.8, and the standard deviation is 0.5 kilograms. Does the sample mean differ significantly from the intended weight of what here? 16. The intended weight of 16, of course, this 16 here will be the population weight, the population mean. Now, listen, you know, when these people, for example, the ones who sell to us loaves of bread, these guys have got their intended weight. There is that weight that they would want us to believe their bread in this case here weighs. Perhaps it will be, like, say, 1 kilogram. So they would want every consumer to know that their bread is a kg. But unajua sababu ya wizi wanaweka ingine kidogo. So then what will happen? We now, as people who are coming to give assurance to the public, will go, for example, to a supermarket and take a few loaves of bread, like 10, and then we weigh them. Chances are the ones that we weigh, which perhaps could be 10 loaves of bread, the X bar will be like 0.8. So X bar is the sample mean. X bar is always what here? X bar is the sample mean. And then, of course, our mu should be what here? Should be the population mean. Don't confuse between the two. Okay. Now we go to number two. Number two is very serious. This has been tested in your exam severally. So they're saying here, prices of shares of a company on different days in a month were found to be, they are given there. Discuss whether the mean price of the shares in the month is 65. Discuss whether the mean price of the shares in the month is 65. The mean price for the month is 65. Now look at this. These guys here, they have given us a sample of the daily prices. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 prices. So the first thing that I'll do, even without much really struggle, is to appreciate there that we've got 10 samples. We've got 10 samples. We have got 10 samples. And if you've got 10 samples, ladies and gentlemen, there is no problem. 10 samples. Of course, we appreciate the fact that we are using what? A small sample. So we have picked 10 days, a sample of 10, a sample of 10. So this is a sample of 10, which in this case is less than 30 again. So this is what we call a small sample, a small sample. So very important. So from there, then what we shall do, come and put down, in this case here, your allegations. Put down your allegations. So we have the null. Null means no difference. Null means no difference. So we have the null hypothesis. So we have in this case here our null hypothesis H0, which will be something there. And then of course we have our alternative hypothesis, which I would want to see whether there is anybody who will be able to put those down very easily. Could you kindly try putting down those metrics easily? What is a null hypothesis? What is the alternative hypothesis? Just try, we see. So one thing that I would want you to appreciate as we begin, ladies and gentlemen, is that this monthly price, the monthly average, becomes our standard, becomes our whole population. So the population mean there is 65. The population mean is 65. This population mean being 65, then what I would want to prove, ladies and gentlemen, is that whatever sample mean that I've picked there should be exactly equal to who? The U. The population mean. Remember those prices, the daily prices could be lower or higher than 65, Or in this case, ladies and gentlemen, we could have in this case here, the alternative now will be the alternative. So we have here, first of all, it's the quality that we don't have any difference, but the difference is what? Nil. And then we have in this case here, because the price, the daily prices here could be higher or lower, then the alternative will be X bar is not exactly equal to mu. Is not exactly equal to mu. From ladies and gentlemen, come and give us the tool. The tool, again, you've told me here that you're using what here? We're using T. But for purpose of reading, practicing how to read very well, I would want us this time around to use significance level, which is abbreviated as alpha, to use 10%. 10% alpha level. 10% significance level, 10% significance level. So alpha equals who? Alpha equals 10%. Alpha equals who? Alpha equals 10%. Alpha equals who? Alpha equals 10%. Alpha equals 10%. So here they haven't given us, we are just assuming. Simply say assumed. Alpha is 10%. Now, ladies and gentlemen, because of this inequality, what I'll come and do here is to have my two tails, because the prices could either be lower or what here or more. The two tails like that. So could you kindly give me the area of one tail? Who can give me the area of one tail? The area of one tail. The area of one tail. The area of one tail. Somebody give me the area of one tail. Somebody give me the area of one tail. This has been tested not once, not twice in your exam. Unfortunately, you don't have to get all the marks. No. For hypothesis, you don't have to get all the marks. If you get more than 50%, the better for me, right? So in this case here, Ada has already seen the concept here that because we've got two tails that I must share into this. So come and divide this by 2. So this will be 0.05. This will be 0.05 like that. So the thing that I would want to see whether there is anybody who will be able to get this correctly is the T critical, what we call the T critical. Read this T from your tables, and then you give me an answer. Read the T from your tables, and then you give me an answer. Read the T from your tables, and then you give me an answer. Let's see, abracadabra. Abracadabra, let's see. Sam Lemayan says 1.80. Value of n. Let me give you the value of n. Let me give you the value of n. Let's choose. This is the question. This is the question here. This is the question. So n, when you count them, how many are they? Number of days that you took this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they're 10. They're 10. Great. I mean, it's only Lemayan who has been able to get me the T, really. It's only Lemayan. The other students haven't gotten me the T. Everybody should be able to give me the T. Everybody should be able to give me the T. Everybody should be able to give me the T. So remember, you need two things for you to read the T table. You need two things. You need two things. You need how many things? You need two things. You need two things. You need two things. You need two things. So these things are, number one, you need the degrees of freedom. You need the V. V is what is called degrees of freedom. And for us to get to B, we normally have n minus 1. That's B. So the n here is 10, 10 minus 1, that gives me 9. And then number 2, the other thing that you need for you to be able to read the T table, you need what we call 1 minus alpha over 2. So it will be 1 minus alpha. This time round, we took 0.1 over 2 like that, which will be the same as 1 minus the 0.05, which will be 0.95. So please go to your table and look for 0.95, look for 0.95, look for 0.95 here. So we have 0.95, I mean, 95% up here, 95%, 95%. How many degrees of freedom you can see here? 10, 9, or rather 9, 1.833, this figure here. Great, thank you. So they're telling me that this should be 1.833 positive, on their side will be minus 1.833. Now they know that the unshaded is always at 0. The shadeds are always what here? Alternatives. They're H1s. They're H1s. So ladies and gentlemen, after that, then what do we do? After that, ladies and gentlemen, what do we do? We've been able to put down the T critical. Now from there, we go to the T calculated. From there, we go to the T calculated, the very interesting stuff, and it comes with so many marks. So we have here T calculated. So T calculated, T will be equal to X bar minus mu all over the standard error. Standard error, which is a standard deviation over what here? Root of n. Root of n. But now you see, and this is why I like the CPA examiner. This time around, this examiner has not given you X bar. He wants you to calculate it yourself. He wants you to calculate it yourself. So then what I'll do, he has not given you any parameter. So what I need to do is to come and write down the numbers. What we've got to do is to come and write down the numbers. So we have our X, we are simply tabulating this. We have our X there, we are simply tabulating this. So X is 66, 65, 66, 65, 66, 65, 69, 70, 69, 70, 69, 70, 69, 71, 69, 71, 69, 71, 70, 63, 70, 63, 70, 63. I have to rewrite again. My table will not be enough. So we have X there. We have 66, 66, 65. We have 69, 70, 69, 70, 69, 71, 69, 71, 70, 63, 64, 68, like that. So ladies and gentlemen, I would want to get X bar out of this information. You bright students of mine, all of you are bright. Could you kindly help me out? What do you think shall I do to be able to get X bar? To get X bar is a very simple thing. The first thing you'll do is to come and add. Give us the total. So give us the total here. So come and give us X bar by giving us the total. So X bar will be summation of X divided by N. So is there anybody who is able to give me the summation of X? The level of significance is 10%. We assumed that the level of significance is 10%. 10%. So 10% divided by 2, it came to 0.05, 0.05. Because 10% is for both. So could you kindly give me the total here? Give me summation of X first. Summation of X is what here? Somebody, summation of X? 675. Thank you very much. And therefore, X bar will be 675 divided by 10, which gives me 67.5. Thank you very much. The other thing that I would want you guys to give me very first is the standard deviation. Is there anybody who remembers the formula of getting standard deviation? Is there anybody who is able to remember the formula of getting standard deviation from high school, from wherever? Standard difference from wherever, standard difference. Is there anybody who is able to remember that formula? Is there anybody who is able to remember that formula? Is there anybody who is able to remember that formula? Standard deviation, standard deviation, standard deviation, standard deviation. I'm waiting to hear from you, great students of mine. I am waiting to hear from you, great students of mine. Standard deviation, standard deviation. Because now, unlike the other question, this examiner has not given you the formula. Unlike the other question, this examiner has not given us the formula. This examiner has not given us the formula. The examiner has not given us the formula. Robert, square root of variance, yes, thank you very much. So the standard deviation basically here will be, because we are looking at x minus x bar, we are looking at the deviation of the statistical values from the mean. So then these has to be done what, as usual, squared. And because there are many, you must come and sum. And then you divide this by what here? N minus 1. Because it's a small sample, you must divide by n minus 1. And then at the end of the day, big square root. At the end of the day, we have a big square root. We have a big square root, a big square root. At the end of the day, we have a big square root. So could you kindly come and create a column for the numerator? You create a column here for x minus x bar squared. Create a column there for x minus x bar squared. So like now the first one will be 66, that is x, minus x bar is 67.5. You square this, you get an answer. You got the second one, 65 minus 7.5. You square this, you get an answer. You get an answer, you get an answer, you get an answer. And then you do like that for all of them, And then down here, I would expect you guys to come and give me the summation. Down here, I would expect you guys to come and give me the summation. Remember, it's individual value of x. It's x minus x bar. The x bar now will not keep on fluctuating. The x bar will not keep on fluctuating. So please be very aggressive with this. It may look a little bit technical, but be aggressive. Put down your calculator, stamp down your feet, stamp down your feet, stamp down your feet. Njeri Kitu, with your assumption, I went for 10% because I wanted you to know how to read the table. We can adopt and say, for example, we shall be assuming 5%. I simply wanted you guys to get more exposure in reading the tables. But you can adopt, like now in Jerry, you can say you'll be using 5% throughout. And that person will say 10%. After all your exam questions, the examiner will give you the level of significance. So that should not scare you at all. That should not scare you at all. That should not scare you at all. Okay. The most important thing in Jerry is that you know how to read the T table, regardless of the percentage should be given to you. That is the most important. Because so many students are not able to read the T tables. I can assure you over 90% of the Section 4 candidates don't know how to read the T tables. If you know how to read the T tables, uko mbele sana. Uko mbele sana. Alafu hata ukishindwa kusoma, hata ukishindwa kuweka hizi vitu zote, kama sio ukijua hii kitu ya kutafuta standard deviation, utapata marks mingi sana, standard deviation. Utapata marks mingi sana. So please, with speed, what are we getting here with speed? What are we getting here with speed? What are we getting here? So Robert Doty tells me 70.5. 70.5. Is there somebody who is able to confirm that they get? I would want to see this 70.5 from each one of us. And then our class today will continue to around 2 p.m. 2 p.m. or even 3 p.m. I would want us to clear this thing once and for all. our class will really continue. So please make arrangements for that. Make arrangements for that. We'll only have perhaps a 10 minutes break at lunch time for purposes of prayers. For purposes of prayers. Do we have a Muslim here? Do we have a Muslim here? Do we have a Muslim? Do we have a Muslim? Do we have a Muslim? Yes, then we'll break at around exactly 1 for 10 minutes and then we come back. We come back. Great, thanks, Boru. Great. Okay. But now 70.5 has not been given to me by 70.5 has not been given to me by many of you. 70.5 have not been given to me by many of you. I can see Robert challenging me that even Christians pray. How I wish it would be like that. Yeah, we pray, we are Christians, but you see now, unlike Muslims, we don't keep that schedule, like the exact time. The exact time. So Winnie has confirmed, Becky has confirmed, 70.5, thank you very much. So then come and feed onto this formula, and then you give me the standard deviation. So the standard deviation here will be equal to who? The standard deviation will be equal to who? The square root of this you've told me is 70.5 all over 9, all over 9, all over 9, all over 9. Why 9? Because of 10 minus 1. 10 minus 1. So 70.5 divided by 9, whatever you get, give us the square root. Whatever you get, you give us the square root. Whatever you get, you give us the square root. Whatever you get, you give us the square root. Whatever you get, you give us the square root. So Winnie gives us a figure of 2.7988. 2.7988. 2.7988. Na Njeri sikuona ukinipatia figure ya 70.5. Njeri sikuona ukinipatia figure ya 70.5. Aki sikuona. Usikubali kubaki nyuma at all. Hii ni kitu rahisi sana hii. Ya 70.5, so long as uko na calculator, maybe una calculator. Usikubali kubaki nyuma hii. Hii ni kitu ya maana sana. Yep. Thank you very much for being honest. I'll have to wait for you for even 2 minutes. I'll give you 2 minutes. Hii kitu ya hii kila hata si Njeri peke yake. Hata for example kama mrembo anaitwa nani Kate, haujanipatia. Catherine Mwendo sikuona figa yako. Kuna huyu anajiita data girl. Data girl sijaona figa zako. Na mkono majina mzuri. Kuna Elziver. Elziver sijaona. Lina na Chieng sijaona. Opio niliona kweli? Opio, acha nirudi hapa nyuma nione. Huwa si wakazi namna. Ukiona kazi namna hii, fuata nini wewe. Catherine amepata 70.5. Thank you very much. So please go ahead and feed there. This is very important, and you know this can be a game changer. Paul, they've gone ahead to give me the correct figure of standard deviation. Thank you very much, Opio. Elkana, you've been able to get that. Rita Mweni has gotten standard deviation. Kunupi mwina anajiita CM. CM, jaribu kabisa kwa siku zote. Kama una calculator, please next session na make sure kwamba umepata calculator. Next session na make sure umepata calculator next session. Great. So now I want to believe that each one of us has been able to get this 2.7988. Having gotten this, now there is something that you guys haven't yet done. Remember, there is our formula of T calculated, which needs these figures. T calculated is X minus X bar all over standard deviation over N, over root N. There is this formula here called T calculated that I would want to hear my students just speaking about it. Speaking about it, this T calculated, what do we have there? The 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 T calculated. DJC, Jesse gives me 2.799, no problem. That's slight difference near rounding off error, which is acceptable. Acceptable. Thank you very much. Now I'm looking for the one who will be able to give me the T calculated as the first student, to get T calculated. So many people are not talking to me. Lilian Maingi is not talking to me. Nokia 2.3, you're not talking to me. Roba ameshapata tayari. What is the population mean? Nangojo niambie Boru. Boru mimi nangojo niambie sababu hapo ndio maneno iko. At least the sample mean you know. At least Boru knows one thing. Boru knows the sample mean. But the population mean, how much is the population mean? Becky is getting, they're getting these answers very nicely. Thank you very much. 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 You say Boru. What is the population mean? The population mean is what we believe, right? Our belief is that the mean price for the whole month is 65. Our belief here. We are told, discuss whether the mean price of the shares in the month is 65. So this monthly mean is our mu 65. Sam is quite himself. Him is saying, you guys, maybe you're getting whatever, I'm getting a negative. Those are the kind of students I want now. Sam is saying, Walimu, I'm getting a negative. No. I'm the one who misled you. It is supposed to be X bar minus mu. I'm the one who misled you in the formula. I'm the one who misled you in the formula. I am the one who misled you in the formula. I'm a bad one. I am a very bad one. I'm the one who misled you in this formula. Remember, the formula is, this is the one for getting, if you remember the Z, the number Z, the formula here is X bar, it's two means, X bar minus mu, all over standard deviation divided by root n. So it will be X bar, you guys got an X bar of what figure? Of 67.5 minus the mean which is what here? The mu mean, which is 65, all over the standard deviation that you guys gave me as 2.7988, all over square root over n, which is 10, all over square root of 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 10. Then at the end of the day, we shall be able to get our T calculated as who? Our T calculated as who? We shall be able to get our T calculated as who? Our T calculated as who? We shall be able to get our T calculated as who? Our T calculated as who? I think the positive one is correct, 2.8 something. The positive one is correct, 2.8. 2.825. Opia upon round off sana, 2.825. Now we go to the last stage, which is the decision stage. Let's go to the last stage, which is the decision stage. So what decision do you make? 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 What decision are we making? What decision are we making? Is it in the shaded or unshaded? Shaded or unshaded? Most of them are saying unshaded, unshaded. Remember, you're not supposed to guess. You're not supposed to guess. 2.8 is more than this. 2.8 will be somewhere here because you know you begin from 0. So 0, 1, we go to 2. So 2.8 is somewhere here. This is the number line, right? This is the number line. 2.8 is on the right-hand side of this bigger like that. So this falls on the shaded region. It falls on the shaded region, falls on the shaded region, and therefore we accept H0. Falls on the shaded region, and therefore we accept what here? We accept H0, and therefore we accept H0. Falls on the shaded region, and therefore we accept who? We accept H0. We accept H0. Don't even go further than that to do any descriptions. Simply tell us we accept H0 because I'm giving you so many sorries. It is in the shaded region, and the shaded region happens to be what here? The H1 region. Sorry for that. H1. Thank you very much. Accept H1. It falls on the shaded region, and therefore accept H1. Accept H1. Thank you very much for correcting me. Accept H1. Great. 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 Now, ladies and gentlemen, here we are. There's one more area in this that I would want us really. Okay. So before I proceed, could we kindly try this question ourselves? It is in our past papers. This one of Mwangaza Limited. Mwangaza Limited. Mwangaza Limited. Mwangaza Limited. Mwangaza Limited. I want us to try this question ourselves. And then as you try it, I would want these lifetime hours to be in form of thousands to reduce on our workings. I would want us to have this as 4.4, 4.8, 3.7. Let's work it out in form of what here? In form of thousands. In form of thousands. In form of thousands. I would want to give you like 10 minutes. You try this question very fast and then you advise. You try this question very fast and then you advise. Let's be very serious on it. I'm not even hiding the solution. I'm not even hiding the solution. I would just want you to get more exposure. Yes, I can see Winnie's question. Population mean now will be 4, not 4,000. Thank you very much, Winnie, because our figures are in thousands. So the answer that I'm putting there, of course, you guys are adults. It's not for you to just copy it. No, no, no. At times you can just have a look at it, but for just guidance, for just guidance. Okay, so how do we get T critical? Thank you for asking that question. How do we get T critical? How do we get T critical? T critical is the same as T tables value. So T tables value, you need two things you need. Number one, you'll need the degrees of who? Degrees of freedom. You'll need the degrees of freedom. How do we get this? It's n minus 1. So in this particular question, what is n? Are you able to see n there, Lillian? What is n in this question? What is n in this question? Are you able to see n? Are you able to see n? What is n in this question? Are you able to see n? 10. That's one, which is 9. Then the other thing you need is 1 minus alpha over 2. So then this will be 1 minus, has the examiner given us alpha, or we assume, do we have alpha? Has the examiner given us alpha? Alpha is the level of significance. Has the examiner given us alpha, or we assume? Do we have alpha? 5%. So 0.05 divided by 2. So then this, of course, I'll have to do this separately. So 1 minus this will give me 0.975. 0.975. And once I have that 0.975, then what I'll do, I'll go to my T tables. On my T tables, I have V. So V, I'll go all the way up to 9. And then I have this column here that has got now T.975. T.975, you walk down with it. I'm able to read this figure here. So in short, to demonstrate using the table, the T critical, this is T critical. This is T critical, this is T critical, not this one. Not this one. So you can see degrees of freedom V, you go to 9. And then of course, for T.975, it is here. So at the intersection, you'll be able to see the 2.262. I hope that is helpful. So once you finish, can you let me know that you are finished so that I can go to another project? Look at that conclusion. I love that conclusion. If anybody don't know what the answer will be, what Ada has given me there is so nice. It's so nice. Winnie says, no, Mwalimu, it is 1.3456, which falls on the unshaded region. And if it's unshaded region, we are going to accept H0. Who is telling us the truth? Who is not telling us the truth? So let's wait. Let's wait. Let's wait. Jerry says, my answer is 1.66 false in whatever. Thank you very much. Let's wait for other students. Okay, Robert Doty. Falls within acceptable region, it's 0. Therefore, we accept it 0 and reject. Oh, reject. Very good. I like the responses. 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 So you can see it is here 1.6767 falls on what here? Somebody unshaded region H0 region. H0 region. H0 region. So that is the answer. That is the answer. That is the answer. So all of us, are we on the same table? Same table, same table, same table, same table, same table at the top. We're going to be at a table down there or at a particular table, but on top. We are on top of the table. Have we finished this question, all of us? Can we go to something different? 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 How I wish like I could see 23 yeses. If I could see 23 yeses, I would be very happy. And of course, feel free to ask questions. Always feel free. I'm not a bad teacher. I'm a trained teacher. There is no way you'll ever ask a question, not even a single day, you'll ever ask a question and then I say that's a stupid question. No, nope. I know you came to me because you wanted me to lift you up. Oh, you've never used it. Jerry is very open there. Now this time around, you'll use the table. You'll use both of them. Okay. What if we directly divide 0.05 divided by 2? I know what win is. It win, it's Roma. 0.05 divided by 2. What if we divide? Now you see, what will happen? You'll always have to be careful with the table the examiner gives you. You see, like now here, at times you'll get an examiner who does not give you what? Who does not give you this? Although for CASNEB, always they give us this T point something, eh? But assuming he doesn't give it to you. So what I'll do, I'll come and go for 2 tails, because mine here is 2 tails. The 2 tails, the 2 tails, the 2 tails, and the 2 tails total is 0.05. Or if you want to look at only one tail is 0.025. So what if you take that 0.5 you divide by 2, one and the same. So long as uko na uzoefu wa kuangalia, utaangalia. Lakini sisi table yetu inakuanga the same. Table yetu inakuanga the same, ile ya T.9 something like that. I'm waiting for your consent to be able to continue. I'm waiting for your consent to be able to continue. And in case you haven't been able to finish, because really this was about your practice, I would request that you take a snapshot of the solution and then look at it later. You simply take a photo of the solution and then you look at it later. Make sure that you do practice, you practice. Make sure to practice. Winnie raised, yes, Winnie. Winnie has raised her hand. Let me unmute, give you the ability to unmute yourself, Winnie. Just a moment. Winnie, you can unmute yourself and then you address the congregation.
Yes, Mwalimu, I have a question.
Yes, Winnie.
Now, if you don't want to draw this thing to know whether it falls on the shaded or at the unshaded area, you can just say that if T calculated is less than T critical, you accept, or whether it is greater, you accept or you reject. How do you handle that?
Normally,
instead of drawing this?
Yes, good question. Normally we normally use that approach when we have got just one tail. If you have got one tail, then you can go straight away and say, when this calculated is less than this. But you see now here we have got how many tails? We have got 2 T's. So the 2 T's will be very hard for you to address it the way you want us to look at it. We have 2 T's, one is positive, another one is negative. And that is why we draw this thing. And that is why even if you look at your solutions, CASNEB solutions, you will see a student who has drawn that gets a mark. It's important to draw. Don't go for shortcuts, Winnie. Any other question before we go to something different? There are students that would want to hear their voices, but they are not talking at all. They are not talking at all. Very good. The Lillian asks here, how do you tell whether it is 1 tail or 2 tail? There are some marks, yes. How do you tell whether it is 1 tail or 2 tails? Remember when we started there? Okay, that also tells me that Lillian has not watched some video. There is a video that I sent to you some time back, Lillian here, of hypothesis testing. Have you watched that video, Lillian? Have you watched that video, Lillian? Yes or no? Have you watched that video, Lillian? Yes or no? Yes or no? Yes or no? Yes or no? Ah, okay, then no wonder. You see, if, for example, your alternative hypothesis says X bar is greater than mu, you want to test the allegation, or rather, let me use less. You want to test, for example, there are some members of the public who have come, in this case here, making a lot of noise to Kenya Bureau of Standards, that the kind of bread we're getting nowadays, the weight is so little. So then you would want to go and test this hypothesis. So of course, you go to the manufacturer will tell you, no, our sample weight is the same as what here, the population weight. And then we as Bureau standards people would want to test the allegation that the mean weight here is less than. You see now less means what here? One tail. So it will be a one tail and it will be the less tail, which is on the left-hand side, on the left-hand side there. On the left-hand side there, on the left-hand side there. The same is applicable if this was to be greater. You'll have had this kind of an arrangement, but this time around the greater tail. But anytime you have something like this, not equal, straight away that means what here? It means that you have got how many tails? Two tails, because it could go either way. And you refuse either way. So there's a video which you need to get Lillian, which will be able to explain that further. Now I can't really introduce the entire thing here. So I can see it's prayer time, prayers time, exactly 1:10. All of us should be back here at exactly 1:10. Don't log out, although you can also log out and then you come back at 1:10, and then I'll be the one buying lunch today, right? I'll be the one buying lunch today. I hope you're back and we can continue. Are we back? So I would want us to look at the paired hypothesis. The paired t-test. The paired t-test, matched paired. The paired sample t-test, sometimes called the dependent sample t-test, is a statistical procedure used to determine whether the mean difference between two sets of observations is zero. Don't bother about that description. Look at illustration 1. The data below shows the number of students enrolled in 6 colleges for a certain course before and after the course was advertised. Before and after the course was advertised in a certain publication. So we have the colleges 1 to 6, number of students here before advertisements, and then we have number of students here after adjustments. So we want to know whether the advertisement was effective or not. Using the paired t-test, determine whether the advertisement was a success at 5% level of significance. Ladies and gentlemen, the first thing that you need to do in any paired t-test, you know, we have got these pairs. These are the colleges. We have these students here before, and then the other pair talks about students in these colleges after advertisement. The first thing that you do in any paired t-test is to subtract the two. Ndio tuone kweli kama kuna any difference ama hakuna. So you take in this case here 165 minus 170. Please give me these differences. Create this table. Write down the table. Let's write down the table. Write down the table as it was provided in the exam. So we have college there. We have college here. Paired t-test. I love paired t-test. So 1, 2, 3, 4, 5, 6, right? And then we have here before advertisement versus what here after advertisement versus after advertisement. So before advertisement, we have 165 we have 140, we have 143, we have 160, 160, we have 162, 162, we have 154. That's before advertisement. After advertisement, there was some improvement. I can see we have 170 there. We have 141, 141. We have 142, 142, 142. We have 167, 167. Then we have 168, 168. And then we have 157. We have 157 like that. 157 like that. 157 like that. And we are saying if it's a paired, I may forget about everything, ladies and gentlemen. I may forget about everything that I'm going to be taught today, but there is one thing that is very clear with me. If it's a paired, where we are pairing data, we'll need a column for what here, somebody? For differences. We'll need a column for difference. So please give me the difference. Please give me the difference. Please give me the difference. Difference 165 minus 170. Give me the differences very fast. Give me the differences very fast. Give you the differences very fast. Very fast. Very fast. What do we have there? Difference means you're subtracting, right? Difference means you're subtracting. So the first one will be minus 5, right? The first one will be 165 minus 170 minus 5. The second one will be minus 1. The third one will be positive 1. Fourth one will be minus 7. This is minus 6. This is minus 3. So please give me the total of all the differences. Give me the total of all the differences. Not absolute. Not absolute. Don't give me absolute. Not absolute. Minus 21. So after getting that, I would expect you to, of course, these are our X variable. These are our X value of our variable there. I would expect you to go ahead and give me X bar of these differences. So it will be minus 21 over how many? 1, 2, 3, 4, 5, 6 over 6. Minus 21 over 6, minus 21 over 6, minus 21 over 6, minus 21 over 6, minus 21 over 6. Is there anybody who is able to give us really? Is there anybody who is able to give us really that X bar? X bar. X bar minus 3.5. Thank you very much. Minus 3.5. Minus 3.5. Thank you very much. So minus 3.5. So X bar for the differences is minus 3.5. Now, please go ahead and give me the standard deviation of the differences. Write down the formula. Write down the formula. Give me the standard deviation of the differences. Write down the formula. Give me the standard deviation of the differences. Write down the formula. Give me the standard deviation of the differences. The standard deviation of the differences. The standard deviation of the differences. What shall we get? The standard deviation of the differences. So when I hear this thing of standard deviation, I'll remember the formula. I know that standard deviation. I know that standard deviation. I know that standard deviation is X minus X bar squared summation divided by N minus 1. And then at the end of the day, root. So I'll come and create a column up here for X minus X bar squared. Very interesting. Very interesting. So like now the first one will be minus 5. This is X. Minus X bar itself is negative. Don't forget. X bar itself is negative, which is, you guys gave me negative, yes. So minus X bar itself, which is minus 3.5, like that. You square, you give me a figure. Remember, we have got this minus for this. and then x bar itself is minus. So in the calculator, what you do, you say open brackets, minus 5 minus 3.5, you close, and then you square, and then you square. Robert tells me that the first answer is supposed to be 2.25. How about the other students? Robert tells me the first one is supposed to be 2.25. Is that correct? Robert tells me, thank you very much. So someone else has confirmed 2.25. Thank you very much. So please pick the second one. It will be the x figure, which is minus 1, minus for the formula. And then, of course, remember that our x bar is negative 3.5, like that. Whatever difference I get, I square. Whatever difference I get, I square. Whatever difference I get, I square. So please give me all of them. Please give me all of them. So according to, I've seen some new students now have started commenting. Thank you very much. So we have 6.25. So could you kindly give me all of them? Kindly give me all of them. Kindly give me all of them. Kindly give me all of them. The paired t-test. The paired t-test. Give me all of them. You guys can even go ahead to calculate all of them. I'm only interested in the summation. 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 So according to Winnie, she's getting 33.5. Winnie is getting the 3.5. I don't know whether I'm the one who was wrong because I got 47.5. I got a summation of 47.5. You can see here in my book, I got 47.5. I could be wrong. 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 I can see people are supporting my answer. Winnie, check again. Check again. Winnie is, great. It's 47.5. Thank you very much. Thank you very much. Now, having gotten, ladies and gentlemen, having gotten my total summation here, having gotten my total summation here as 47.5, for sure, I'll now be able to give you the standard deviation of the differences. Because I have my formula up there. It is root of this 47.5 over n minus 1, that is 6 minus 1. So 47.5. So Sam Lemayan is giving me a figure of 3.08. Sam is giving me a figure of 3.08. Is that correct? 3.08. Is there, and Jerry is also getting the same. Thank you, and thank you very much. Thank you, and thank you very much. Now, have these people given us degrees of freedom? Have they given us degrees of freedom? Have they given us degrees of freedom in this question? Do we have degrees of freedom, or I should mount it up? I think I should mount it up for all of us to see. We should mount it up for all of us to see. We should mount it up for all of us to see. We should mount it up for all of us to see. 5% level of significance. 5%. Now let's start doing this question procedurally. Let's start doing this question procedurally. So the normal procedure now would be, first of all, we set the hypothesis. So first, we set the hypothesis. So the hypothesis, we begin with the null. So the null hypothesis, these are paired t-test. If it's a paired t-test, normally what we do, we assume that really there is no significant difference. So no difference between the two pairs. No difference between the two pairs. Null hypothesis, no difference between the two pairs. Because null means not changing. Null means not changing. Null means not changing. Null means negation, negative. So there is no what here, there is no difference. 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 There's no difference. And then now number two, we imply that there is a difference. So H1 alternative is that there is a difference. Now, after that, we go to the tool. The tool, again, these are 6. So it is a t-test, right? So this t-test, ladies and gentlemen, I'll just come and draw my table here. Not table really, but my diagram. For paired t-test, all paired t-tests are 2 tails, right? So I know this shaded is H1, this is H1, this will be H0, right? Right. So after that, ladies and gentlemen, what I'll do, I will come here and get degrees of freedom. So degrees of freedom, degrees of freedom, degrees of freedom. Remember, degrees of freedom is n minus 1, n is 6 minus 1, which gives me 5. This is one of the things that are required for us to be able to read the T critical. And then number 2, we have 1 minus alpha over 2. 1 minus alpha over 2. So then this will be 1 minus 0.05 over 2. So 1 minus 0.05 over 2. 1 minus 0.05 over 2. Which will end up giving us what figure? Which will end up giving us what figure? Can somebody give me number 2? 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 I know quite about it offhand. It has to be 0.9 something, 0.9 something, 0.9 something, 0.9 something, 0.975, 0.975, like that. Then could you kindly go ahead now to your tables and read for me the T critical? Go to your tables and read for me the T critical, given those 2 things. The T critical here will be, because now we are talking over 0.975. So 0.975 is here, 5, the 5th one, 2.571. Let me get to hear from you. Yes. Is it 0 or 2? Be careful, Jerry. Jerry, be careful. 2.571. 2.571. So this becomes 2.571 positive. This becomes negative 2.571, like that. So this is H1. We know this is H0. Now from there, we'll go straight away to the test itself now. We go straight away to the test itself. Let's go straight away to the test itself. Let's go straight away to the test itself. So the test itself, what do we have here? The test itself, we calculate what we call T calculated. So we have what we call T calculated. So we have what we call the T calculated. So the T calculated, what do we have here? Under T calculated, we know the formula. T calculated is x bar minus mu all over the standard deviation that we have divided by root n. Divided by root n. Divided by root n. So I would want you to take this opportunity to substitute there. I would want you to take this opportunity and substitute for us. Give us the T up there. Give us the T up there. Give us the T up there. What do we have? Somebody try to substitute. try to substitute. At least you got X bar for the differences. You got X bar for the differences. So when you go to this exam and you hear an examiner talking of paired T, the first thing is the differences. Next, I'll be able to get X bar for the differences. I get the standard deviation of the differences, and then I start my procedure of hypothesis testing. I start my procedure of hypothesis testing. I post the question right. Great. Posted the table. Nope, should not have been the table, really. Should have been the question. So I'm waiting for an answer or a question. You know, it's either you have an answer or you have a question. So we start with, thank you, Winnie. We start with X bar. Are you able to see X bar? X bar of the differences. What is the X bar? Minus 3.5 minus 0. Minus 0. This is what I wanted to sell to you today. That the mean population of paired t-test. Paired t-test, its mean population is always 0. Paired t-test, it has a mean population of what here, somebody? 0. Paired t-test. Paired t-test has a mean of what here, somebody? 0. So Becky, you have to cram it that way today. But now after you pass and come to CPA section 5, I'll be able to tell you, for example, no, if there is no difference, those perfect, this before advertisement, after advertisement, those things as they get your difference minus 1, another one should be plus 1, so that the population mean should cancel out to 0. The population mean should cancel out to 0, but the very best, given the proximity of our exams, I can't really belabor to explain this point so much. The very best thing at times cramming assists. What have we said about paired test mean? Paired test U. Paired test U is always equal to 0. Is always equal to 0. All over the standard deviation. Are you able to remember? I rubbed mine long time ago. Is there somebody who can give me the standard deviation here for these differences? Standard deviation for the differences. Standard deviation for the differences. What do we have there? Somebody, standard deviation for the differences. Standard deviation for the differences. So standard deviation for the differences was 3.08 divided by square root of 6. Remember, it's the division. So you should even get this division separately. You take this divided by root of 6. So minus 3.5 divided by this quotient, you should be able to give me the T calculated. This is T calculated. This is T calculated. This is T calculated. So our T calculated will end up by giving us what figure? Our T calculated. Our T calculated. Our T calculated. Our T calculated. I'm being told is 0.9791. 0.9791. So of course, now you guys are good scholars of this subject. Go ahead and place this T calculated. Place it here. Place it here. Place it here. Place it here. Place it there. Place it there. Tell me where it falls. Somebody, you guys are expert now. Tell me where it falls. The 0.9791, shaded or unshaded? Shaded or unshaded? Shaded or unshaded? Shaded or unshaded? T calculated is supposed to be 2. According to some, T calculated is supposed to be 2.783. So I'll not say whether it's right or wrong. I would really wait for other students here to give us an answer. I would really wait for other students to give us an answer. I would really wait for other students here to minus 2 point. Check this again. Minus 2.781, minus 2.781, minus 2.781, or 84. Thank you very much. So in that regard, could you kindly tell me where this minus 2.784 falls? Is it on the shaded side or unshaded side? Shaded or unshaded? Shaded or unshaded? So somebody tells me it is shaded. So if it is shaded, in this case here, accept what here? H1. Accept H1. Accept H1. Accept H1. Accept H1. Accept H1.